This is a video on how to use the statistics spreadsheet program, Statistics by Larry Green, to perform regression analysis. So let's suppose we have some data. Let's suppose that X is going to represent the percent score a student gets on the midterm, and Y represents the percent score that student gets on the final exam. So I want to put in my data. So the first thing I have to do is I'm just going to clear out what's here for the X and Y. So I just go there and hit the backspace, highlight it out, and hit the backspace. And then I type in my data. So let's suppose the first student got an 87% on the midterm and got a 94% on the final. So I type in 87 in the A2 entry and 94 in the B2 entry. And then I keep going and type in the rest of my data. So I'm almost done typing in. Notice as I type in, the graph and all the numbers change as I go. It's kind of cool that it actually updates it as I type. So I'm going to type in 88 for the next student, and the final exam was a 79. And then the next student got a 94 on the midterm, and also 94 in the final exam. I have one more to type in, which is a 45, unfortunately. Didn't do so well on the midterm, and didn't do so great on the final either, got a 66. And notice as I type it in, a dot will appear. Okay, normally you're going to have a lot of data. I'm just typing in some to show you the idea. If you have it in another spreadsheet, you can copy and paste it in. That works just fine. What I want to do next is I want to look at all of the different statistics and our scatterplot and regression line and show you what we can do with it. So first, we have R is equal to 0.866 about. So we have a pretty strong correlation is what that means. Anything over 0.8 is a pretty strong correlation. R squared is equal to about 0.75 or 75%. So what that tells us in a way is it kind of says that there's going to be a variation in the scores. You can see in the final exam scores, there was a big difference between one score and the next. If you happen to know what the midterm score is, then kind of on an average, that variation, like that standard deviation, is going to be decreased by around 75%. It's kind of the idea of R squared. As he predicted, it's kind of like a standard error or a standard deviation type of thing for regression analysis. I'm not going to go into that. We have a plus bx. That's the equation of the regression line. So we could say that the equation of the regression line is y equals about 28 plus 0.67 times x. That tells us that our best prediction for a student who would get a score of 0 on the midterm would get a score of 28% about on the final exam. Again, it's just a prediction. And it also says that kind of on average, a general trend is that for every additional percent score above the last one that students get on the midterm, their score in the final is predicted to go up by about zero point 0.7 or 0.67 points. N is 12. That just means that there were 12 different students we looked at. We can conduct a hypothesis test for the correlation. If you have a two-tailed test, that means H1 is that the correlation is non-zero. We can see that our p-value is really, really small, 0.000269, etc. So that tells us there is statistically significant evidence to say that there is a non-zero correlation. You could do a left-tailed or a right-tailed test also instead, and that would give us the p-values for those. If we want, we could predict y given x. So let's suppose we want to find out our best prediction for a student who scored, let's say, 80% on the midterm. I just type in 80, hit enter, and we could say that our best prediction for a student who scored 80% on the midterm would be that that student scored about 81.5% on the final exam, just a prediction. And then finally, we could take a look at the graph. We have a scatter plot, and we also have a regression line. So here's the scatter plot, the regression line. We can see that the scatter plot is somewhat tightly drawn to that regression line, and that's reinforced by our R being 0.866. We can see the slope is positive, as we saw before. We could also change this scatterplot and regression line. We could change the name of it if we want. We could change the x and call it something else if we want, say midterm, and we could change the y to final by typing that in. There's a lot of flexibility in this program. So I hope you have an easy time using Statistics by Larry Green to perform regression analysis. And notice that it does most of what you need. If you have any questions, shoot me an email at drlarrygreen@gmail.com. That's drlarrygreen@gmail.com, and I'll be happy to help you out and maybe even add stuff if you have some suggestions. So thank you very much for watching this video.